we're going to go through some projectile motion problems. So what is projectile motion? Projectile motion pretty much involves throwing something. When you throw something, it generally follows a path like that, okay? So you're at a certain height here. This is where the ball or rocket or whatever starts from. And when you release the ball, it rises till it hits a peak and then falls until it hits the ground or wherever, the water or whatever we're talking about in context. So let's take a look at how these questions work. So a golf ball's path is modeled by h equals negative 16t squared plus 45t. H is the height and t is time in seconds. So using technology, sketch a graph of the golf ball's path, and we want to show all the important features of the graph, such as the vertex, the y-intercepts, the x-intercepts in the context of the problem. So to do that, let's go to Desmos, and I'm going to put in y equals negative 16 x squared plus 45 x. There we go. Okay, now we have to think about the part of the graph that matters. The only part that's going to matter here are positives, because remember, on the x-axis, x here, or t, stands for time. You can't have negative time. And on the y-axis, or the h in this problem, height, you can't have negative heights. Okay, so we have an x-intercept of 0, and we also have an x-intercept of, by the way, all I'm doing is tapping on the points to see where those x-intercepts are. We have an x-intercept of 0, and we also have an x-intercept of about 2.81, and the vertex is at 1.41, let's say, and then 31.6. Okay, so let's make a rough sketch of that. Let's start with the intercepts. We got the intercepts at 0, and we also have intercepts at 2.81. So, draw my axes. X-intercept there. Here's 1. And let's label our axes. So this would be t, which is seconds. H, which is the height. Okay, and then we said our other intercept was at 2.81, so 2, 3, so it's around there. And let's get our vertex. Go back. The vertex was at, what's that point? 1.41, 31.64. Okay. Should notice the vertex is halfway between the intercepts. So out there. Okay. And what was that number again for the y coordinate? 31 point, let's just call it 31.6. Okay. So this is 1.4, 31.6. Okay, and 2.8 will suffice here. I don't need 2.81. And there's our graph. Okay, so let's say this is going to be, this is a 31. So let's say 30 right over here. 20, 10. Okay, so this is a rough graph showing, oops, I don't know what I did there. Okay. Showing the path of the golf ball. So the golf ball starts at the ground. You're hitting it off of the tee. So for the first about 1.4 seconds, the golf ball rises. It reaches a maximum height of about 31.6. And this is height, it's in meters. So for the first 1.4 seconds, the golf ball rises. It reaches a maximum height of about 31.6 meters. And then for the last 1.4 seconds, it falls and it hits the ground. It hits the it hits the ground at 2.8 seconds. So first 1.4 seconds rises, goes to a max of 31.6 meters. The last 1.4 seconds, it falls and it eventually hits the ground at 2.8 seconds. Okay. How many, this is say, after how many seconds? Wow, that's some great handwriting. After how many seconds after the ball is launched does it take to hit the ground? Okay, so two ways to do this, right? We know the ball is going to hit the ground at about 2.81 seconds, all right, from the graph. But you should also know we have this equation h equals negative 16 t squared plus 45 t. You should also know how to solve it algebraically. So when it hits the ground, this means the height is 0. So we want to solve 0 equals negative 16 t squared plus 45t. Okay, and this one is actually factorable. It factors by GCF. So we have a GCF of t here. So we can go t times negative 16t plus 45. And then we can break each of the factors apart to be just t equals 0 and negative 16t plus 45 equals 0 minus 45 minus 45. Negative 16t equals negative 45. T equals 45 over 16, which on the calculator, 45 over 16 is, about 2.81. Okay, after how many seconds is the ball 10 feet above the ground? If it's 10 feet above the ground, that means h is equal to 10. So we have our equation for the position of the golf ball, negative 16t squared. So we want to solve the quadratic equation 10 equals negative 16t squared plus 45t. So I'll subtract 10 from each side. So we have 0 equals negative 16t squared plus 45t minus 10. Okay, and we don't want to try to factor this. Let's put this in the quadratic formula. So quadratic formula, x equals negative b plus or minus square root b squared minus 4ac over 2a. So that would be negative 45 plus or minus square root of 45 squared minus 4 times negative 16 times negative 10 over 2 times negative 16. So that's negative 45 plus or minus square root of, 45 squared minus 4 times negative 16 times negative 10. So that's square root of 1385 over negative 32. So that's negative 45, plus or minus square root of 1385 is 37.2 over negative 32. 32, and we'll break it apart. That means negative 45 plus 37.2 over negative 32, comma, negative 45 minus 37.2 over negative 32. All right, and let's see, negative 45 plus 37.2 over negative 32 is about 0.24. And then the other one, negative 45 minus 37.2 divided by negative 32 is about 2.57. Okay, so we have two times, we have where the ball reaches a height of, so this should be 10 meters, not feet, okay? We have two times where the ball reaches a height of 10 meters at about 0.24 seconds, as well as 2.57 seconds. All right, what is the maximum height that the ball reaches? How long does it take to reach that height? Okay, so the maximum height is the vertex, right? We know our vertex is 1.4, so, and the rest of the vertex is 31.6. So that means after 1.4 seconds, the golf ball reaches a max height of 31.6 meters. All right, number 2. Coin is thrown from a bridge and its path is modeled by that function. After how many seconds is the coin 30 feet above the water? So that means h is 30, so we want to solve 30 equals negative 16t squared plus 96t plus 112. Okay, I'm going to subtract 30 from each side to get in standard form. So we have 0 equals negative 16t squared plus 96t plus 82. So let's put everything in the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So x, or well, x real here is really t, equals negative 96 plus or minus square root of 96 squared minus 4 times negative 16 times 82 all over 2 times negative 16. Okay, so t equals negative 96 plus or minus square root of, let's see, 96 squared minus 4 times negative 16 times 82, square root of 14,464 all over negative 32. So the square root of 14,464 is about 120.27. Negative 32. So we have, probably should have left more space, plus 120.27 over negative 32, comma, negative 96 minus 120.27 all over negative 32. So let's see what that comes out to. The first one comes out to, let's see, negative 96 minus plus 120.27 divided by negative 32. That's negative 0.76. And the bottom one, let's see, negative 96 minus 120.27 all over negative 32. That's 6.76. Okay, so looking at our answers, the first one for this, when we split up the plus minus, came out to negative 0.76 seconds. Well, that's not possible. You can't have negative seconds, so we are going to exclude that one from our answer. And the only time at which it would make sense in the context of problem is after 6.76 seconds, coin hits the water. Okay. Last one, part C. So the maximum height, that's going to be the vertex of the parabola. We don't have the graph, so we know the vertex is at x equals negative b over 2a. Let's copy the function. H equals negative 16t squared plus 96t plus 112. Okay, so it'd be negative 96 over 2 times negative 16, which is negative 96 over negative 32, which is 3 seconds. Okay, so it reaches the maximum height after 3 seconds. Let's see what the maximum height is. So we're going to substitute t into the function. The height after 3 seconds is negative 16 times 3 squared plus 96 times 3 plus 112. So that is negative 16 times 9 plus 96 times 3 plus 112. 256. And that's in meters. So maximum height that the ball coin reaches, 256 meters. How many seconds does it take to reach that height? That is 3 seconds.